Hi, everybody. My name is Zen Honeycutt of Moms Across America, and I'm here with Dr. Stephanie Seneff. Hi, Stephanie.
Hi, how are you?
I'm great. Thank you. We're so glad to have you on here today to bring some awareness to your new paper that is out. But first, let's establish who you are for our viewers.
hmm
Who are you? And give us a little bit of your background.
Okay, I'm Stephanie Seneff. I'm a senior research scientist at MIT, where I've been all my research life has been at MIT, including my education. So I have background degrees, multiple degrees from MIT in biology and in computer science and electrical engineering. And the last 10 years, I've been researching autism and zeroed in on glyphosate, which is the active ingredient in the pervasive herbicide Roundup, about maybe 5 years ago. And I've just basically really focused on studying glyphosate since then because it's a very fascinating molecule. And I am increasingly convinced that it is a core reason why the US has a healthcare crisis today. So I think it causes much, much more than autism, and we need to get rid of it. We need to ban it from the earth. That's my conclusion. So.
Excellent. Well, we agree. And I'm not a scientist like you are, but from talking to all the mothers that we speak to about switching over from GMO foods, which are sprayed with glyphosate, or non-organic foods, and then we see their children get better when they avoid those foods and glyphosate. We have come to the conclusion as well that it is extremely harmful and that we want it banned from the planet as well. So thank you very much for making that statement, because it does take some courage. I mean, this is a $40 billion a year business for many of the chemical companies, and it's a behemoth sort of thing, right? It's a big.
I know. It's amazing, actually, how much control they have over the government and how willing the government is to go ahead and poison the population because of the money issue. Is just absolutely amazing to me.
Yeah. So before we get into the science, I do want to ask, what makes you uniquely sort of qualified to do all this research on glyphosate? Can you talk a little bit about how you have at your facility the ability to scan thousands of documents
Right.
and all of that?
Yeah,
Can you talk a little bit about that?
sure. I think my computer science background is really very powerful in conjunction with my biology background, because many of the computer scientists don't really understand the biology and they just kind of throw numbers at it. They get stuff, they don't understand it. Whereas I have an interest in biology as well. So I'm combining the two, and then I can go and use the computer science to study the research literature with the computer to help me to sort things out and organize and find common threads, and then figure out puzzles. And I love figuring out puzzles, and the computer helps me do that. So it's really a lot of fun. I love my research, and we're getting all these correlations too. We go and get a lot of statistical analyses and see very strong correlations, and we can compute the p-value, the significance values with 0.00001 significance for correlations between things like autism and glyphosate. So that provides a very powerful backdrop for the idea that glyphosate might be causing autism. Of course, correlation is never proven to be causal until you can understand the underlying biology. So that's where I've been focusing, and that's so fascinating to understand how glyphosate works in the body to cause harm. And it's an amazing molecule.
So
And we're very fascinated.
how many documents would you say that you have had access to through your computer science to be able to scan and to pull information from?
Well, I don't know. I have, probably tens of thousands of documents on my computer, and I put various packages together with various topics and then number crunch those to come up with words and correlations, and then try to use that to help me solve the puzzle. So I'm finding pathways, and different metabolic pathways that are disrupted. And the whole field of biology is full of incredibly complicated information. Biology is so amazing with its complexity and all the signaling, that goes on, and all this causes that. And it's just very, very difficult to sort through all of that. But I feel that we're really, the team that I'm working with, we're really cracking open this nut and figuring out particularly autism, but also many other of the diseases that we're seeing. For example, anencephaly, which is what we'll be talking about today. When you take a particular disease and then you take a bunch of data and a bunch of articles and you number crunch it, and then you can help to sort everything out and figure out the larger story, which is the part that I find really fascinating. The story that ties all of that information together and makes sense out of it.
Great. So let's get into that. And with the understanding that you haven't done a study with 2,000 rats that took 5 years to come up with this conclusion or theory that you have, that you present in your paper, right? This isn't.
No, it's a review. In a sense, it's a review paper.
Yeah.
In fact, one of the frustrations is that there isn't really a category for the kind of paper that I write, which is the kind of paper I think is really one of the most powerful kinds of papers one should be writing, where you gather the evidence from the existing research literature and then build this larger story that explains the pathology that you're observing and try to connect to do things like proving that a chemical is causing a disease, through the evidence that's already in the research literature.
The way that I look at it is that you're doing like a Google search of thousands of documents, and you're pulling this information. The most pertinent is coming to the top, and you're presenting it to the public. Like, look, this is what could be happening.
Yes.
And then you get criticized, and frankly, we get criticized for showing your science because, like, well, it hasn't been proven. Well, but if you look at the thousands of documents and the millions of words of information out there and you pull this together, I think as a mother, I have a right to know that this is what's coming to the top, right? That this is what you suspect to be a major contributing factor to anencephaly. So let's talk about that. So let's say, what is anencephaly?
Yes.
And why should we be concerned about this? What is anencephaly?
So anencephaly literally means no brain, and it's a very severe disorder in a child. The child's not viable. They usually die shortly after birth. The child is born without a cerebral cortex, so there's basically no brain. The neural tube, when it was developing in the very early stages of the pregnancy, the neural tube has to close, and when neural tube closure doesn't work correctly, then things really get messed up in the continuation of that development of the brain, and the entire cortex just basically gets aborted. It just doesn't happen.
Well, and this is devastating, and it's been happening at higher levels. I happened to meet a woman who works at a high-risk OBGYN office, and she said she's seeing more and more birth defects, anencephaly, and also where the organs are outside of the body.
Gastroschisis. It's another form of neural tube developmental problems. That's also probably caused by glyphosate. Gastroschisis, it's the same thing. I mean, a different part of the neural tube, but the same problem, which it would make sense that it would cause that too, given what we found. It's all kind of the same, has a lot of commonalities.
Okay, so let's talk about how could glyphosate cause this? What do you see from your science? What's happening?
Well, that's where it's a very, very long list, and it would take too long for me to tell you everything, but I do have the paper, and so with a paper that I wrote together with Dr. Greg Nye, and you're going to show it to them here in a moment. This has just come out on the web. It's published in this journal of neurology and neurobiology. Open access journal. So if you want to learn all the gory details, download that paper and read it. It's really, I think, remarkable what we found. We suspected anencephaly because we were seeing it particularly in Yakima Valley. That's what really caught my eye, and that's what caused me to get interested in this topic, because Yakima Valley in Washington State, it's a big river system. There's a Yakima River that kind of goes through this valley and supplies water for the irrigation system for the crops that grow along the edges of that valley. And they were having troubles with an invasive weed. And they had a deliberation, and they decided that the best thing to do was to use glyphosate in the water to control this weed. And they did this over a period of a few years. I think it was like 2010 to 2015. And particularly high levels of glyphosate were used in 2012 and 2013, which was when they had the peak. Over that whole period, they had way too many cases of anencephaly in that area compared to the average. It was like, 5 times as high as the normal rate. Normal, of course, is a bad word because there shouldn't be any anencephaly, in my opinion. Anyway, they, of course, didn't have any clue that it could be glyphosate because they never, ever think of glyphosate. And this is what frustrates me. And so they, but anyway, when you look at the data, it's very compelling that the glyphosate usage corresponds to the anencephaly. And therefore, this gives you, again, it's a correlation idea, and it gives you a hint that glyphosate might cause it. which is all I need to then go after the research literature to try to see if it is plausible, to look for plausible reasons why it could. And I hit gold. I mean, it was just incredible. And we call this death by 1,000 cuts for a good reason, because there were just so many different ways in which glyphosate would disturb neural development, particularly the closure of the neural tube.
So let's look at that. Here's the article. Should we go over the abstract first, sort of the summary of what you found?
Yeah, sure.
Okay. So tell us about this summary. So you say that here that we review a multitude of ways in which glyphosate can detrimentally impact or cut embryological and fetal development to specifically favor the anencephalic phenotype. Can you explain how does it cut?
Well, we use the term cut because we like the title "Death by 1,000 Cuts," but basically it's destructive of many different pathways. A lot of it has to do with various problems with different nutrients that are crucial for the development. One of which, of course, is retinoic acid. Retinoic acid is famous. That's vitamin A. It's famous as a cause of neural tube defects when there's too much excessive retinoic acid. And this is something that's quite straightforward with regard to glyphosate, because glyphosate disrupts cytochrome P450 enzymes. And you've talked about this before in the liver, which are important for detoxifying things. Many other toxic chemicals get detoxified through these CYP enzymes. But one of the things they do is to metabolize retinoic acid. And they're actually produced in the neural tube during development. And there's a crucial timing situation that goes on. It's quite interesting because the neural tube produces retinoic acid, and then it depends on the concentration to control what goes on in the timing of the development. And then the retinoic acid needs to fade away. It needs to be actively removed in certain parts in order to trigger a next stage in the development. And if it isn't adequately removed, then that stage won't happen. So that's a way that you can get an abortion of the step that's going on to close the neural tube at the cranial region, so that you're going to produce then this, go forward to this next step of building the brain. So excessive retinoic acid.
Let me try to wrap my head around this. So you're saying that, so the body develops in stages, which makes sense, right? Energy needs to flow to like the heart and then the lungs or whichever. I'm just making this up now, but stages, right? Mm-hmm. And so there's a certain stage in which the neurotube is being developed and it needs to close so that then the brain can develop.
Yes, that's right. And that can get all messed up if there's too much retinoic acid. It doesn't get adequately removed.
And how does glyphosate impact the retinoic acid, though?
Because it produces, so the CYP enzyme is produced, but if the glyphosate's there, it's going to disrupt the CYP enzyme's ability to do its job, which is to remove the retinoic acid. Now, there's another one, vitamin D, which is the same thing again, only it's different. Vitamin D actually gets activated by CYP enzymes. So these enzymes are really, really important, and they're getting disrupted by glyphosate. Vitamin D doesn't get activated, again, because of the CYP enzyme disruption, and that ends up being a deficiency in vitamin D, which we have an epidemic in that, but that's also linked to anencephaly. Women who have low vitamin D are more likely to produce an anencephaly, a child with anencephaly. That vitamin D is also critical for development.
Wow. Okay. So the glyphosate disrupts the CYP enzyme.
Yes.
And that ability to stop the making of the retinoic acid. And then the retinoic acid keeps being made, and then the neural tube does not close. It stays open.
Yes.
And so then the brain doesn't form because the energy doesn't.
Yes, it doesn't go on to that next stage of development.
Wow.
Yeah.
That is fascinating. Okay, so so glyphosate is sort of cutting off that ability for the next process is what you're talking about.
And there's just so many things that go into the timing to make that work properly. It's amazing actually that it works as well as it does most of the time. And you can scroll down here and get to that table where I have the various nutrients. I talked already about retinoic acid. There's a couple tables in here that kind of focus the discussion right here. And you can see this list on the left of the nutrient and then the mechanism on the right. Zinc, cobalamin, folate, retinoic acid, which we've talked about, methionine, and vitamin D we've talked about as well. So we've already covered two of these. Methionine is a really big one because you probably know about methionine deficiency and methylation impairment, which is linked to autism, impaired methylation capacity. You probably may have heard about all of that. And so methionine is the core amino acid, sulfur-containing amino acid. And I've talked a lot about sulfur because glyphosate is an absolute train wreck for sulfur, starting with an inability to convert inorganic sulfur into methionine, which is an organic form of sulfur, in the gut by the gut microbes. So this is an effect on the gut microbes, E. coli in particular. A study showed that E. coli had several enzymes that were involved in methionine synthesis that were suppressed by glyphosate exposure. So this means your gut microbes can't make methionine. It also probably, in fact, they've shown methionine deficiency in plants exposed to glyphosate. So you're going to have methionine deficiency in your diet, and then you're going to have impaired ability to make it in your gut, which is going to lead to an impaired methylation capacity, and methylation is a crucial aspect of development. So that can also cause trouble with the neural tube development.
So and by impaired methylation and impaired development, so impaired development in a fetus,
yes.
How does that impact, I know we're talking mostly about fetuses now, but how would that impact a human being that's already alive to have impaired methylation?
Oh, well, it causes a lot of problems there, too. And I think it's tightly connected to autism. A lot of people have talked about genetic disorders that are linked to autism that involve this methylation pathway. So methionine has this methyl group on it. That's why it has the name methionine with a meth there. And that methyl group, folate, is involved in that, too. And you can see folate's on this list as well. Folate is really a big one that people are very aware of. There's been a lot of emphasis on folate during pregnancy, folate supplements during early pregnancy to try to protect from neural tube defects. And glyphosate disrupts folate because that's a direct product of the shikimate pathway. And glyphosate kills the shikimate pathway. I'm sure you know that. That's the...
Yes.
And so in the gut microbes actually make folate for the host. And I actually found several articles that talked about that, quite remarkable, very clearly that they make the folate for the host. So when that process gets busted because the shikimate pathway is disrupted, they can't do that anymore. The folate becomes deficient. So folate is an enabler of the methylation pathway. So both the folate and the methionine together are going to disrupt the ability to produce these methyl groups and to attach these methyl groups to the DNA, which is a step towards controlling how the development takes place. So it's going to mess up the development in multiple ways, one of which is going to be the anencephaly. But various, all kinds of neural tube defects are connected to folate, like spina bifida, for example. I mean, they actually put folic acid into the wheat. They made a law to do that in 1998 to add folic acid to wheat because they were aware of this problem of neural tube defects probably increasing right before that. And of course, they've interestingly, and we talked about that, I think, in this paper, they monitored the folate levels in pregnant women in a period of time after they introduced this folate into the food supply over from 2000.
Did you say 1998? They made
1998. They started adding folic acid to the wheat, and then they monitored the women from 2000 to 2005, and they found that their folate levels actually went down. So despite getting more folic acid in their wheat, it wasn't working. Basically, folate levels were dropping in the population. I think that's because on top of that was this rapid growth in the GMO Roundup ready crops, which was offsetting any gains they were getting from the folic acid in wheat.
Yeah, well, because we know now glyphosate sprayed on wheat as a drying agent.
Yes.
That's a chelator. It draws out the vital nutrients or makes them unavailable to any living thing it touches. So it's going to impact all of these things that, like you're saying, the zinc and the folate, just from that chelation effect by itself, right?
Yes, the chelation is what's going to disrupt the zinc, but more than that, and I didn't realize this until I wrote this paper, I know glyphosate binds tightly to zinc, and it disrupts all the metals. I know all these minerals that are so important, zinc and iron and cobalt, manganese, they're all disrupted by glyphosate. But zinc in particular was quite interesting because papers showed that in the presence of glyphosate, the liver produces a huge amount of a protein called metallothionein. And metallothionein loves zinc. It takes in tons of zinc. It like binds to zinc like a magnet. And it actually prevents the zinc from getting into the general circulation. So the liver hogs the zinc inside of these metallothionein molecules that it's massively producing in the presence of glyphosate. And this causes a zinc deficiency. So when the mother's exposed to glyphosate, she makes lots of this metallothionein. The zinc gets trapped in it. And then the zinc is deficient in the rest of her body, including in the developing fetus. And then zinc deficiency is a very strong, also a very strong factor in neurotube developmental problems. So that's just another nutrient that gets messed up. But both through the chelation by glyphosate, but also through the absorption by this metallothionein.
Right, and when a male is exposed to glyphosate and the glyphosate goes after the zinc, then his sperm levels are going to be diminished.
That's right.
Quality of sperm, and we're seeing that.
Absolutely.
Yeah.
Yes, the epidemic in male infertility is very scary, and I think that's glyphosate's a direct hit there. I'd like to write a whole paper on that at some point.
Yeah, absolutely.
And then we have one more here, which is cobalamin. That's also a super, super important nutrient that's also linked to neurotube deficiencies. And that's B12, vitamin B12. And this one actually has multiple ways in which glyphosate disrupts it. It messes up its synthesis because there's a critical first early stage in its synthesis, this ALA pathway. ALA step is disrupted, and it also chelates cobalt, making that unavailable. That was shown in cows, severely suppressed levels of cobalt in cows exposed to glyphosate. So that's going to be a double hit on cobalamin. Cobalamin and folate are both really important for this methylation capacity. So all of that is disrupted by glyphosate. Now we can go down to the other table.
Okay. 1 second.